Okay, new topic. We are into quadratics. For future reference, if you're trying to tell the difference between quadratics and parabolas, quadratics is the algebra side, parabolas is the graphing side. So they're almost exactly the same thing, just depending on the context. Cool. There is going to be several ways that we're going to try to factor quadratics. We're going to go through them in a very specific order. But for now, we've got recognition is going to be the new thing. However, you already know one way to factorize, which we were doing last topic, which was taking out common factors. So henceforth, I'm just going to refer to that as common factoring. So for a little bit of practice, let's do some common factoring to make sure we remember how to do things. If I've got this thing, great. What do I have in common? They both they both divide by 2 rather. So I'm going to take the 2 out the front, this divided by 2, this divided by 2. Beautiful, done. Nice and boring. Can we check if we've factorized correctly? Well, yeah, we just do the reverse. Reverse of factorizing is expanding. We expand these brackets out, I get 2 by x, 2x, and 2 by 3, 6, so I get 2x plus 6. Brilliant, we know we've done that right. Cool, what if I've got this thing? Well, what do they have in common? Go with the coefficients first, 12 and 8, they both divide by 4. Oops, no bracket yet. Okay, the x's, I've got an x squared and an x cubed, so I take the lowest power in common. Y to the 3 and a single y, so I've got a single y in common. Open up. 12 divided by 4, 3. 3 square, x square and x square, that's the same, so that's a 1, but 3 times 1 is just 3, so I won't bother writing the 1. Y cubed divided by y gives me y squared, minus 8 and 4, that gives me 2. So this is power of 3, this is power of 2, so I've got 1 left, don't have to write the power of 1. Y and y, that's just 1, so I'm timesing by 1, I don't have to write it because I've already got stuff in there. Beautiful. If I expand this, I should get back to where I started. You can always pause and make sure. Cool, what about this thing? Well, what have I got in common? 9, 12, 15. I've got 3 in common. Okay, great. I've got an x squared, an x, and no x, so I don't have x's in common. So all I can take out is that 3. Get 3x squared minus 4x plus 5. Check if you expand out that it all works out. Brilliant. So all of that's just common factoring. Great. We're going to move into factorizing by recognition. Now, why do we do this? Well, basically we do this because this doesn't work anymore. If we take a look at this first guy, x squared, 5x, 6, I've got nothing in common, right? I've got no x's here. This only divides by 5 and 1. This doesn't divide by 5. All I've got is divide by 1, which doesn't do anything. Well, that's no good to me. Well, we can still actually factorize this, even though it looks like we can't. So, what are we going to do? I want you to think about x plus a, x plus b. I want to expand this thing out. Okay, well, we'll do a lovely rainbow thing. X by x is x squared. X and b gives me bx. A and x gives me ax. A and b gives me ab. Cool. Alright, well, can I shuffle this around a bit? Yeah, I can. This whole thing is x squared plus, I've got a whole bunch of x's, ax's and bx's. I'm just going to put them in alphabetical order. So I've got a and b. Where's the blue? There it is. Plus, where'd my x go? Plus there and x there. So I've got a plus b, lots of x, plus ab. We'll do it in purple. Why not? Coolly. Alright, so great. Why did we do that? We just did some expanding. I thought we were talking about factorizing. Well, let's think about this for a second. That means that if I have x squared by itself plus some amount of x plus some other pure number, I should be able to take it back to this form. So this is the factorized form of this. This is the expanded form. Okay, so now we have to do a little bit of thinking. Alright, well, 2 numbers that multiply to the n number. Well, I could have 1 and 6, could have 2 and 3, that's it. Those same 2 numbers, a and b, have to add to the middle number. Okay, well, 1 and 6 is 7, that's no good to me. 2 and 3, yeah, that works. So, I can rewrite this as such. So I've got my two numbers times to the end, my two numbers add to the middle. Okay? Well, we should always check if this works, so x by x, x squared, x by 3, which we did in red, 3x, 2 by x, 2x, and 2 by 3 is 6. Is this the same? X squared, yes. 3x and 2x makes 5x, yep. 6 is 6, beautiful, we know that that works. Okay, so that's the gist of recognition. All you're doing is, so long as you've got x squared plus some amount of x plus some number, or minuses for that matter, you'll be able to potentially do recognition. So, next guy down. I need two numbers that times to the end and add to the middle. Numbers that times to 8, 1 and 8, 2 and 4, that's it. Okay, which of those adds to 6? 2 and 4 adds to 6. Okay, so I've got x plus 2, x plus 4. You can expand this out to check that that does indeed go back to this. Okay, well, what if we've got this? So now I've got a minus. Is that a problem? No, because back here we just had a and b. A and b could have been negative, that's not a problem. Alright, so I need two numbers that multiply to negative 8 and add to positive 2. Okay, at this point you might be fiddling around in your head a bit because negatives are a bit hard to keep track of. So maybe we want to write a list. Maybe we want to go 1 and 8 multiply to this, 2 and 4 multiply to this. Okay, I need one of them to be negative. Okay, so I'll go negative on this side and then I'll write the same thing with negative on the other side. Cool, okay, all of these pairs will multiply to negative 8. Great, which one adds to 2? Negative 1 and 8? No. Negative 2 and positive 4? Yeah, that works. So that's what we're going to use, just for completeness. 1 minus 8? No. 2 minus 4? No. So you should always get this unique output. Cool, okay, so we're going to have, remember it's x plus a, x plus b, and these are our a's and b's. So x plus negative 2 is the same as x minus 2, and x plus 4. And again, you can expand out to check that you do indeed get back to where you started. These are very easy to check if you've got right, they're just a bit fiddlier to actually do. Beautiful. Next one, okay, I've got two sets of minuses. Is that a problem? No, not a problem. A's and B's could be anything positive or negative. Okay, well, what multiplies to 10? I've got 1 and 10, 2 and 5, that's it. I could make these negative, or I could make those negative. They have to add to negative 3. Negative 1 and 10, nope. Negative 2 and 5, that's positive 3, but we want negative 3. No, and that's negative 3, so it's the last one. Cool, so I've got x and positive 2, x with minus 5. Beautiful. And again, you can expand to check that it works. Cool. That's the gist of all this. Now, there are a couple of special cases. When first looking at this, you might say, oh, I can't use this anymore because I need x squared to be by itself. And typically, you can only use it for x squared plus some, what do we call this? We'll call this bx plus c. Cool. So typically you can only use it on this form where there is nothing in front of the x squared. It's called a monic, as in M-O-N-I-C. Mon meaning 1, or mono meaning 1. So a monic quadratic means that you've just got an x squared by itself, not 2x squared, 3x squared, whatever else have you. So we've got a 2x squared. That looks like we can't use this. However, we should always go down our list of the way we learnt it. The first kind of factoring we learnt was common. Is there something in common? Well, yeah, everything divides by 2. So I can go 2 lots of x squared minus 2x minus 3. And now I can examine just this bit here. Can I factorise that? Well, numbers that times to negative 3, well that's 1 and negative 3, or I could have negative 1 and positive 3, and that's it. Alright, 1 and negative 3, that adds to negative 2, so yeah, that works. So this bit, I've got x plus 1, x minus 3, but I can't forget I've still got this 2 out the front. Beautiful. And indeed, if you expand this out, you should end up back there, so that works just fine. So just because there's something out the front doesn't mean that you can't necessarily use recognition. You just first have to look for a common factor. Brilliant. Cool. What about this thing? Well, this guy doesn't even have a C. That seems a bit weird. Well, as before, don't start at recognition, start at the very top. Is there something in common? Oh yeah, there is, there's x's. So we'll just take the x out the front. X, and then x minus 6. Beautiful, you're done. Because I can think of this as having its own brackets. Or if you want to be super weird, you can write it like that, which is a little bit weird that you're writing plus 0, but now it looks the exact same form. Typically you'll just write it as this, commonly without those brackets. But that's fine. So always try to do common factoring first. The numbers get smaller quicker that way, it usually helps you out. Then try recognition. There are, however, situations where that won't work. So if we look at this, we go, well, I could do common first, okay. So I've got 2x squared plus 4x plus 5. Oh, that didn't get rid of everything. Can I do common again? No. So now I actually am stuck. I can't factorize that by recognition or by common. I don't have a way of dealing with this yet. We'll get there. Not today, but we'll get there. Cool, I've got this. Well, okay, is there anything in common? No. Hang on, I don't have a b in here. That's a bit weird. I don't know what to do with that. So this one, we don't know how to deal with yet. Again, we'll learn how to do it later. This guy, it looks like we're okay. Oh, okay, well, -1, what multiplies -1? 1 and -1, or -1 and 1. Well, these add up to the same thing. They both add up to 0. Well, that's a problem because I need to get to 2. So right now, we don't have a way of dealing with that because we can't think of any numbers that multiply to -1 and add to 2. Okay, this guy, well hang on, now we've got extra y's in here. We've got extra variables floating around. Well, that's even more confusing. Strictly speaking, you can do this by recognition if you're a little bit crafty, but generally, not really. We need a different method to deal with that. So I'm not expecting to deal with these types just yet. All the ones that you'll look at will either require common factoring and or recognition. So you're looking for, is there anything in common? Take that out straight away. Great. Can you now find something that times to the end and adds to the middle? Beautiful. You've got your sheet with all the different exercises for things. Best of luck. Email if you do get stuck. Cheerio.